If I could direct your attention up here. Alright, so obviously we're just trying to calculate for g, so g is equal to t. G is equal to 4 pi squared times the length divided by t squared, right? That's just rewriting this in terms of g instead. Got that right? Yeah. So now there's a couple important issues, Dave and Joaquin, that I haven't covered yet. And the main thing is that you see that this is a constant, right? Do you think constants have zero error, right? Do you think that would affect the error of this length?
Yeah.
Why do you think so?
Well, because if it's like plus or minus 1, let's just say you have like a length of like 1 plus or minus 0.1. Your minimum value is 0.9 and your maximum value is 1.1. If you were to multiply by 4, you get 3.6 and then you get 4.4.
You're right. The error for this length does change if you multiply. But if you add or subtract it, it won't change. And I'll show you again using the formula for the error. So the error for, let's do multiplication. Remember, it's like this.
Oh wait, actually.
Square root of.
I have a quick question.
Yeah.
So like, if you were to treat like the constant as like a variable with zero uncertainty, would that calculate correctly?
Yeah, that's how you're supposed to do it.
Okay.
So, right, so this is just adding all of this up. So what is this q value? This q value
is going to be g? Or, oh, no, never mind.
Squared times the length, right, times 1. So that's just 4 pi squared. Well, 4 pi squared times 1, right? I'm just calculating this numerator right now. I'm doing 4 pi squared. Let's just define this here. Q is equal to 4 pi squared times the length, which is equal to 4 pi squared times 1, right? Times the square root of, okay, so what's the error of this? This is 0.05 over 1 squared, okay, plus, and what's the error of 4 pi squared?
Error of 4 pi squared.
Zero.
Yeah.
It's a constant.
Okay, so then that means that this is just equal to 4 pi squared times 0.05, right? And that's actually the error that you have for this product, okay? And this value is going to be about 1.97. So that means that the numerator, so remember we were talking about this before, like the order of operations things. Yeah, you can consider this numerator as one error and then consider this denominator as another error and then calculate them separately and then divide them. Okay?
Yeah.
So you can't just do division directly because there's a squared here. So you have to first calculate the error considering the squared term.
I mean, I'm like, what if you were to rewrite it as like t times t? Could you
okay,
solve
that's a
that
very
all
good
in
question. The thing is, you can't do t times t because that would imply that the variables are correlated. Or let's see.
What?
That's not, t times t is different than t squared. It's like kind of what I'm saying, and the reason is because I think it gets correlated if you have more than one variable. If you have the same variable twice. Like in all the problems that we've done, we have uncorrelated variables. But if you're doing t times t, these two variables are correlated.
Oh, the first t is going to determine the other one.
Exactly.
Yeah.
So that means you have to use the equation for
because you can't have one that has like the minimum. You can't have a minimum value of t and then the other t be the maximum value because they have to be the same. That makes sense.
Right. So that's why we can't just do it all in one step. We have to calculate the numerator and denominator separately, okay?
Okay.
So this is the error that we calculated for the numerator. Yeah.
I'm just a little confused. So what happened inside of
That's actually really weird.
Yeah.
Inside of the error propagation for q, what happened inside of the, what is it called again? The square root.
Here.
Yeah. So no, under.
Absolute value of a.
Yeah.
It's just so that's just 1 in this case.
So why does it only come from the length?
Because so what we're trying to do, q is 4 pi squared times l, right?
So yeah.
So what's the error for length? It's this, right? It's this term. What's the error for 4 pi squared?
0.
Yeah, so that's why it's only coming from the length.
Hmm.
So it's kind of interesting. If you're multiplying a value by a constant, then the error also propagates through the multiplication. Okay?
Wait. Okay, never mind. Just keep going. I'll work it out.
Okay. Let me know if it doesn't make sense.
Yeah, no, I'm confused because I thought I don't know why, but I'm thinking in my head that you would plug in the t value. So why wouldn't you do?
Well, hold on,
something
because
like that?
I'm only considering the numerator first, and then I'm gonna consider
okay.
the denominator. Yeah. Do you remember why we can't do it all at the same time?
No.
Dave and I were just talking about it. Dave, you want to explain?
Yeah, so it's like, so like if you were to rewrite it as t times t,
Oh, okay.
the
So it's
second
the same
t
kind
in
of
there
logic.
is going to be determined by the first t. But normally, if we were to do it as t times t, we're going to treat them as separate variables. But that's when the formula would be appropriate, but it's not because that first t determines the second t's value.
Mm-hmm. Yeah, good explanation. Okay, so this is the error we calculated. So, and q, this value is about, let's see, about 9.9. Okay, so that means that in our numerator we have 9.9 plus or minus 1.97. Okay, now let's calculate the error for t squared. So, actually, so this is the numerator. And the denominator is going to be q is equal to x times n, right? Which is equal to t, which is 2 times to the power of 2. Okay. What's the equation for the error if we're doing squared?
Q over the, uncertainty of q over the magnitude of q, or like absolute value, equals absolute value of n times uncertainty of like your variable, and then divided by the magnitude of it, or absolute value, sorry.
Okay. So in this case, let's plug it in. We would have the error in q is equal to 2 times the error in x, so x is going to be 2, it's going to be the period calculation, or the period measurement, so the error is going to be 0.1, divided by the value of x, which is going to be 0.2, so that means that, this is divided by, I forgot to divide by q, so this is going to be 4, right? So that means the error in the numerator is going to be, wait, hold on, this is going to be 0.4, but I wrote down the wrong number, this is not 9.9, that doesn't make sense. This is 39.48. Okay, so that means that the denominator, t squared, is going to be 4 plus or minus 0.4, right?
Yeah.
So now we just have a simple division, right? So how do we divide? What's the error when we divide?
Error in q, or uncertainty.
Well, first of all, what is q?
Q is going to be like the actual, what are we doing, 4 pi squared L? Or we're just calculating, right?
Yeah, it'll be 39.48 over 4, right?
Yeah.
I'm taking the actual values of these two numbers.
Yeah.
Cool. And then the error in q over q is equal to square root of error in A over A, error in B over B, and you're adding all those together. So, and then when you plug it all in, you probably know how to do the calculations. The error in Q turns out to be 1.1, and then you get the final answer to be 9.9 plus or minus 1.1. So that's your final answer.